Hi, so today we are going to learn about the concept of fail-safe versus fail-fast. So there are two phenomena in Java which happens over the collections. So first let us take an example of the array list. So as we already know that array list basically is dynamic in nature, which means you can add elements to it and remove elements to it whenever you want. Now again, we know that there is a concept of concurrency, or we can say as multiple threads which can work on the same collection. So you can imagine that you have a number of items in a company which are getting sold out very fast, like they are selling different items. So, but people are also trying to purchase. So let's say we have a list, and list is having some items, and someone is trying to buy. As soon as he buy, we try to remove an item, and likewise, it's called a producer consumer program, wherein someone is trying to consume, which means reduce out of the list, and someone is trying to add out of the list. So in the same list there are two operations happening simultaneously, and someone is reading it as well. So we are trying to read it with the example of iterator. So we just created a list iterator, and then we are trying to retrieve the value out of it. Now what happens that whenever there is modification which happens, and we cannot you know we want it to fail, because there is a concept which is called as the stale data. Stale data means which is a older data. For example, I am trying to buy a thing, and thing might have got sold out. The moment I started iterating over it, there were some changes and someone has already purchased that item. So I do not I should not be allowed, right, to buy it again or do any modification. That way we should be, we should exit the program and fail it. So these in this example, I'll just run it and we will understand that meanwhile that we are iterating, if there is any modification in the collection, which means its state gets changed, then the exception will be happening. So meanwhile when you are iterating, it is assumed that collection state is quite safe. If it is not safe, then and there fail fast means it would fail then and there. So now here we are just iterating, and this iteration will not cause any trouble for us, and everything went smooth. But as soon as we realize that meanwhile the pointer is moving from one item to another, and in parallel, or we call it as concurrently, someone is also modifying the same collection. That time internally the Java will throw an error, and the error is called as the concurrent modification exception. So how to get rid of this? So I'll just give you an example. So if you need to add now, if you do the same thing over here, and if you will comment this out, now you will try to do it again. This will print nicely without any problem. And the reason is because this is now sequential, not concurrent. So this has happened properly, then you have added, then you are iterating again, which means concurrent. There are, okay, so what it is trying to say is concurrently line number 46. Let's go here. So you have this list over here. Okay. We just need to initialize it again because it's already there. Cool. So this time it didn't will not give you the problem because this is sequential, and that was concurrent. Concurrent means you are trying to iterate one item and another, and in between someone is trying to modify this. That's why you will get this concurrent modification exception, which is fail faster. Now there is another concept which is called as fail-safe iterator example. So in this case, we have a collection which is called as concurrent hash map. So this is having some safety towards the concurrency or multi-threading, which means that if the same collection is getting modified while you are trying to iterate over it, it would not have any impact. So this happens, for example, you're trying to watch a cricket match, sport, right? If score gets changed, it's not big a deal. You might get a little bit here or there, but it's nothing a major. So what do they do is, let's say in cricket, you have received there was data for four balls have been played and fifth ball is about to get played, but when you're reading, someone added the data of the fifth ball. So what will happen is, still let's try to run this first. So still when you are trying to retrieve or iterate over it, if someone concurrently added another data for this, it won't fail. But the stuff is, why don't it fail? What's the mechanism which works around? So in these kind of cases, what happens is there is something which is called as the cloning or the duplication. So the actual list would remain same. So if someone is trying to add or modify, the actual list would actually get modified. However, whatever you are reading is the last best known state. So you are trying to read from the best last known state, but you will not, um, mm, I mean, whatever the modification is happening, you might not get it, but later on you will get it. So I'll just give you an example over here for this. So you have got this thing here. You just don't try to add any more data. So what you're doing is, when you was trying to access here, you also modified it concurrently, and then you are trying to read it later on. So in the next iteration, as soon as it came here, it is going to create another copy, a duplicate copy, a photocopy, Xerox copy, whatever you can imagine. It came over here, and then it would print the last updated status, whatever was there. So that's how we see that this guy has got now the last updated status here, which got added. And in this iteration, if you're trying to add anything more, for example, if you will still add something more over here, that would not impact, and this will still go fine. This will go through without any problem. So first, it printed over here. Let's try to run it and make it as 10. So if you have added your this data when this was getting modified, we'll try to print it again, because at the same time when you try to add, it would not get added in here because you are iterating over the copy. Let's try to run it real quick. So you got the data over here. So that is how it works, is whenever you're trying to, let's try to add it again here and say 10 and run it. So you see only one 10 comes here, and this 10 when got added over here, and then as soon as you try to print it, whatever was the last updated state of the collection, that would get copied whenever you're trying to run it. And whenever you're trying to make modification to that, it would actually happen to the original collection and it won't impact the copy here. That is called as fail-safe, which means if you are trying to make modifications in the collection while it's iterating, it would not fail. It is safe from the failure, as the name suggests. That's why we call it as fail safe. However, here, if you're trying to make any changes and then it would fail fast. Means as soon as it knows that there are any modifications which are happening, it would fail. And another technical reason, if you understand, is how array list works is it would do a copy, and it does the dynamic expansion. So initially it would have 10 data, for example, and it would have the space for 10 data. After some time, whenever you add some record, let's say 11th record, it is going to have a space of 20 data, and 9 would be empty. It might use one only, but it has to move entire stuff in the stack from one place to another, copying and pasting, and a lot of stuff happens. That is why, to be safe, if you are trying to make any modification when this thing is already in movement, they would fail it faster. They would fail it then and there, and then they would say, hey guys, now you're done iterating everything dynamically. It might have reallocated its another space with whatever is the expansion, and no one is modifying it safe. Then you can iterate over it. So since it's failed fast, then and there, as soon as concurrency, or when you're iterating, you're making modifications, then it fails. It is something like you're trying to repair a car which is in motion. The first thing they say, boss, get your car to the garage, stop it, stop the engine, then the mechanic would work. You cannot do both, that drive the car and repair the car together. You have to stop it, and then once it's repaired, you can run. You can modify engine, and then you can run. So you're trying to add data, then you're trying to modify data, and then you're trying to again retrieve data, whatever, something like that here. So this concludes the lecture for fail safe versus fail faster.